In this video, we have two trigonometric integrals to evaluate. The first one is the sine of 7x and the cosine of 7x. So it's got the same angle. For this particular one, it could be done because the derivative of sine is cosine and the derivative of cosine is minus sine. We could set up a regular u substitution by letting u equal to sine of 7x or u equal to cosine of 7x, and that's going to work. Now for number 2, we can't do that because the angle is different. It's x and 3x. So that type of substitution won't work. But we do have some identities. Now the ones I'm going to use for these problems will be number 1. We know that the sine of twice an angle is equal to 2 multiplied by sine of a cosine of a. Breaks up that way. And if you have the product of sine of a, sine of a, sine of b, two different angles, there's the formula. If it's sine of a, cosine of b, there's your formula for number 3. And then if it's the product of cosine and cosine with different angles, there's your formula there. So I'll be using the first one and the third one. I could also be using, because I have sine and cosine for number 1, I could use the third one, sine of a, cosine of b. That will also work. Now the answer is going to look different, but it'll be another correct answer. You could check it by computing the derivative, simplifying, and so forth. But let's look at the first one then. Now I'm going to write it this way to save some steps here. I'm going to rewrite the integral as 2 sine of 7x cosine of 7x dx, and I got the 1/2 over here. So it's the same thing. 1/2 times 2 gives me the 1. So then this is equal to 1/2. And then this part right here in the integrand, that's the first formula in red that I just went over. I can rewrite this as sine of twice the angle. The angle in this case is 7x, so that would be 14x, and then it's dx. Then it's just a simple integration here. This would be 1/2. That stays out there, and the integral of sine is minus cosine of the angle. In this case, it's 14x. But then the derivative of 14x is 14, chain rule here in reverse, so this will be a 14 here. And then it's plus the constant of integration. And then you can check it here. If you take the derivative of cosine, it's minus sine, and then you have a minus, so it will become a plus sine of 14x. And then you multiply by the derivative of 14x is 14, and that cancels this 14. Of course, the 1/2 is the factor over here, but we're focusing on this right there. Let's just simplify this and write this as minus the cosine of 14x over 28. And it's plus the constant of integration. And like I said, there is another way we could do it. This is just one way here. Now, this one here, let's review the formulas. When I was given a test on these types of problems, I would pass out a formula sheet. One side, I'd list all the main formulas, and then I'd give that to the students, and then I would tell them, on the back, you can write whatever other formulas you want. Because these are kind of hard to remember. Now, they can be derived using those cosine of a plus b, identities, or sine of a plus b, or a minus b, or a plus b, whatever. But that's the way I used to do it. I'd go ahead and put out some of the main identities, maybe 30, 40 on one side, and I let the students take that formula sheet home the day before the exam, and then they could write as many identities as they wanted, as many as they could fit on a regular page on the back side. So for this one, it's sine and sine here. It's this one here. I had it in red, but no, this one has sine, so I got to use the other one. I'm going to use this one right here. So if you have the product of sine of some angle times sine of another angle b, it can be expressed as a difference right here. So it's 1/2 cosine of the difference of the two angles minus cosine of the sum of the two angles. So then this would equal to the integral of 1/2, and it's the cosine of the difference of the two angles. So it's x minus 3x. That's minus 2x. But keep in mind that the cosine is an even function. So the cosine of x is the same thing as the cosine of minus x. So I can write this as 2x instead of minus 2x. And then it's minus the cosine of the sum of the two angles, x plus 3x is 4x. Don't need parentheses here, but just to emphasize it, I'll go and put it in. And then this is dx. And then this is equal to 1/2. Now we just integrate. I could break it up into two integrals, but we're going to integrate cosine of 2x and minus cosine of 4x. Let's keep the brackets here. The integral of cosine is sine of the angle. In this case, it's 2x. Again, chain rule in reverse. The root of 2x is 2. So that goes to the bottom here. And then for the next one is, again, the integral of cosine is sine of the angle, which is 4x. And then you got the minus here, so we carry that over. And then the root of 4x is 4. So that goes in the denominator. You got the constant of integration. And then we just multiply through by the 1/2. This will be equal to 1/2 times this. 2 times 2 can be 4. So it would be sine of 2x over 4. And the other one, again, 1/2 times the expression. The 2 multiplies the 4, so this is going to be sine of 4x over 8. And then it's plus the constant of integration. Thanks for watching. We'll see you next time.